So this is a current project that we're working on with AgriFutures. It's about water security. So this is we don't have any final results or anything of this. We're sort of in the middle of a bit of modelling and collecting a bit of data, doing survey stuff at the moment, but it was probably a useful opportunity to let people know what's going on, and also, the opportunity to ask people if they want to give us a bit of feedback on the project as well. If they want to, if we've got some opinions and stuff they can share with us, that'd be good. So a bit of context for the project, obviously, due to recent droughts and stuff, so the chicken meat industry is sort of not alone there on water shortages and responses to climate change, less rainfall, more sporadic rainfall, and even increased water demand from other industries and stuff as well. So water is obviously a critical input for production. And obviously hotter places, you certainly need more water, and we know they can't survive without drinking and cooling water for very long birds. So security of supply is paramount with farms, often only have a few days of supply in hand for emergencies. So that's been a fairly typical thing with meat chicken farms, and it's probably can essentially get away with that a lot if you're on town water and stuff. But it's with these increased droughts and longer droughts and stuff, it's obviously a good time to think about, do you need more secure supplies of water, and do you need to be able to store more water on farm, and what does that look like? Just on to the next slide. The project objectives, I'll just read them out. This is a current project. So we're looking at reviewing regional water use by the chicken meat industry, identify water security issues currently affecting it, and identify likely impact to what climate change scenarios might look like. So that's where we're basically looking at doing some modelling with futuristic type met data, if you like, is probably a good way to describe it. So what's the rainfall and variability of that rainfall look down the track to 2030? I think we actually have got going out to 2035 with that. Determine water policy settings that would ensure water security for the chicken meat industry. Identify some novel solutions to improve the water use efficiency and water harvesting. And one of those is around like closed loop water usage, which I'll talk a little bit about later on, and identify barriers to those within the industry. Just on to the next slide, onto the stages of the project. So probably split those into three. So one of them is about water scarcity and security. And we're doing that through some stakeholder consultation. Also looking at the impact of, climate change, whether you get more or less rainfall, and economic return. Looking at those barriers, as I said, to closed loop water systems, use of water data to identify opportunities and barriers that might be there, and then pathways to improve water security, improving use and supply, and improving allocation security, which might be around like policy settings and so forth there as well. So just onto the next slide on the consultation process. So we've set out surveys to grower farms through some of the major processes. So the first round of consultation began back in June, and some of our responses there are a bit limited, that we've had issues with other surveys with the industry lately, certainly, which some virus that you've probably all heard about. So we've actually engaged in a second round of consultation back a few weeks ago. So we're hoping to get some of that data in the next couple of weeks. So this time, not than just growers, we've targeted some water authorities. So trying to target some people in the policy area, going to the farmers' federations as well, because sort of filling them in on the project, but getting their ideas on water security and so forth. Talking to the Chicken Grower Council reps from each state, and also want to target some other regions. So we haven't got responses from all the major chicken growing regions, and then maybe expect we're not going to get from all of them, but we certainly want to get some response for places where water is scarce and chicken meat production happens. Just on to the next slide on the grower regions. So there's just showing the slide on the right there where some of our survey responses have come from, and yeah, are currently pretty much on the eastern seaboard, but we have talked also some people in South Australia and Western Australia as well recently on some of the issues there, particularly in South Australia with water security for the chicken meat industry, which has been a challenge there. So yeah, we certainly want to target some more of those in as we get more survey results back. Just on to the next slide, our survey questions. So there was just a list of questions in there. Your position in the industry, obviously the region you're located in, because that's going to affect your water security and water scarcity there. What are the key factors that affect water security in the chicken meat industry? And some specific questions around if you've ever had to reduce numbers or destock due to water shortages, which is obviously getting to the last straw. Buying in water due to water shortages or changing water sources. So yeah, needing to put bores in if you've run out of surface water, for example, or needing to switch to town water when your surface water runs out, which can be a fairly considerable expense that some people have had to do. What is your water source? The security of your supply. So how secure do you think it is? The amount you're actually paying for it. So the cost of water is obviously pretty critical, and that'll vary around the country. How would you relate to the quality of your water supply? So that sort of relates back to the survey and the project and stuff that Steve was talking to you earlier about. Also, yeah, we're just looking for novel solutions on what you've done when you've had water shortages, what people have been able to do to get around that, whether that's saving water or coming up with other ways to get water. How likely to consider strategies to deal with water shortages. So we've got a number of strategies in there, and then rating it from more likely to not very likely that you look at it, at those options or those strategies, and what are the barriers to water security in your region. So it's a bit more of a general question, that one. So just on to the next slide on the survey results. So this is simply just looking at where your water actually comes from. So the sources of water, yeah, most of it you see is coming from bore water from the survey responses we've had so far. Next, water supply schemes, then towns, and then stream supply. And we'll obviously build on that as we get some more survey results in. This is the one around asking about alternative strategies. Are you likely to look at it or not? Very likely. So capturing overland flow, that was, yeah, a lot of the responses are around that they probably wouldn't look at that, but a few people, you know, if you're in the right circumstances, they might. So changing the water source, again, not likely, because in some cases it's not an option to try and change it. So there's some of the results we're starting to collate from the survey. As I said, they're still interim. So then looking at things like barriers to water security, seeing again if you got no barrier right through to a definite barrier, and there's nothing really showing up there greatly, and it's probably a regional issue as well, which we'd probably want to break up further when we look at these surveys. But certainly a big percentage of the respondents were starting to think about it and what some of those barriers might be there. One part of the project so this is sort of something that we're looking at and to help the industry with sort of policy change around the value of water. So for a whole bunch of references from the Reserve Bank and research reports and ABARES and stuff, started to collate some information on the gross margin of water per megalitre. So they're in thousands of dollars per megalitre on there, and you'll see chicken meters over on the right hand side, and it's yeah, pretty high return. So that's obviously gives a good lobbying base for policy sort of settings, policy changes around the value of water, something you can go back and lobby to governments on, that, you know, the industry has a high value for water, and then combined with that with the expensive infrastructure that's been put in, and yeah, including like industry regions and stuff as well that are going to include things like abattoirs and lots of labour and stuff there as well. So the return per megalitre is quite high from what we've found from the literature and yeah, other reports. Just on the next slide. So one of the other things we're looking at is climate change effects. So we've picked 4 regions in there to look at, which we've started doing some modelling on. You're looking at rainfall and evaporation values used to calculate a range of scenarios using runoff for a design farm in each region. So looking at, well, sort of gets to how do we look at closed loop stuff on a farm, and it's about how much of your water can you actually catch on your farm, and look at that as a closed loop option. It's a bit more obvious looking at closed loop stuff where we're looking at it in the processing industry, because some of the processors actually do have a closed loop system with their water where it's treated basically back to A-grade water and completely recycled back into the processing plant after going up through a fairly extensive treatment process. So this is just one we're looking at, well, what can farmers do on the farm, and what might that look like if you wanted to try and catch your water and use that in your production system, obviously with some treatment and processes and stuff as well. So to be able to do that, we need to be able to look at some of the predictions. So we've used some models on, the next slide, on looking at a range of possible scenarios out to the future on what reduced rainfall and stuff might look like. So there's our 4 areas we've picked there. We've looked at what modelling from CSIRO and the Bureau of Met have come up with in terms of worst case, medium change or best case scenarios for the 4 different seasons in those 4 different areas. So hopefully we don't see worst case, but we've done some modelling around that anyway to look at that, as well as what it might look like if there's a medium change. But in most cases, that is certainly looking at reduced rainfall. Just on to the next slide, I'll just give you a bit of an example on a runoff model sample that we're doing. This one's for the Riverina. So we've basically looked at if you cat a design farm, I think we used like 10 sheds, 50,000 birds a shed, catching the water off the shed roofs and the surrounding roads and so forth. We did a bit of sort of iterative process to come up with how much water you could supply. So you set some parameters around that, saying that, well, we only want the dam to be empty for 1% of the time. So we started off with like supplying 100% of the water, and then got down to a size for this region, for this scenario, of 30%. So this is looking at an example of a covered dam, so actually covering the dam so you don't lose evaporation, and also we'd look at the difference without the cover. So looking at how often that dam has actually got water in it and can supply your water, and in this case 30% of your water at the farm, because you can actually make the dam bigger, but then obviously that comes with a higher capital expense to do that. So there's some of our preliminary results and some of the work we're doing in this. Thanks to AgriFutures for supporting this project, and also thank you to people that have put in some surveys and stuff and responded to us. And if anyone else wants to talk to us, you can get either of us there on those contact details. Just on the next slide, I've got some contact details there. So that's it.